Okay, so we're going to do a little video here on solving one variable equations. So first we're going to talk about what is a solution. So if you're going to solve a equation, we want to talk about what that solution means. So here you can see in the notes that a solution makes the equation true. And if you have an equation, you have an equal sign, and you have two things on each equal sign, or each side of the equal sign. So when we say that it makes it true, it means that if you substitute in that number, then it'll make it the same or equal on both sides. Okay, so we're going to try this out. So the question here says x equals 3. Is x equals 3 a solution to this equation? So we're going to substitute in that 3 for x everywhere we see it in that equation, and we're going to see if it makes it true. So we have both sides here. We're going to see if the 3 in this side gets us the same result as it does if we put the 3 in on the other side of the equation. So here you can see that we're substituting this in, and you can pause this video at any time to write this stuff down to get it in your notes, or just go through it. Alright, so we can see here that 3 times 3 was 9, and so we substituted that in, and then the 2 times 3 was 6, so we essentially have this equation here. We know that 9 minus 4 is 5, so 2 times 5 is 10. So we have 10 on the left side of the equation. On the right side, 15 minus 6 is 9. So the equation just basically says that 10 is the same as, or 10 is equal to 9. And we know that's not true. So therefore, 3 is not a solution to those equations. We're going to try it again here in this equation. X equals -6. Is it a solution to this equation? You can see here that we're substituting this in for x, and we're going to do the same thing that we did above. So we've substituted the 6 everywhere we've seen an x. So -6 times -6 is a positive 36 minus 6 equals, and then we went over here and said 2 times -6 is -12 minus 3. And if we remember our sign rules, which are going to be very important in solving equations, -2 and -3 we need to add together to make -15. So then -2 times -15 is 30, as well as 36 minus 6 is 30. So here we can see that this states that 30 equals 30. That is a true statement, so therefore -6 is the solution to this equation. So there are 3 different types of solutions or answers that you can get in a one variable equation. One, you can get one solution, which we've just looked at. We know that the 6 was the solution to that equation. The other answer is no solution or infinite solutions. So when you look at one solution, you'll find that these are just some examples, that x would equal -2 or x equals 5. X can be a fraction like 1/2. It can be a decimal. It can be this, anything that that you solve for. Okay, it's not limited to whole numbers or integers. It can be decimals, fractions, any of those answers. So you're basically saying x is this. It is this one answer and nothing else works. The other option is that there's no solution. That means that there's not a number that you can put in the equation that will make both sides equal. It doesn't exist. It's not out there. One of the hints here that you can see as you're working out equations is that when you have a no solution, the variables will cancel, meaning that on both sides of on opposite sides of the equal sign, you have the same variables, and we'll get into that a little later, because when you put them together on the same side, they'll cancel out, so the variables will completely be gone, and your constants will still remain. So you'll get 0 equals and then a number, like 0 equals 4. Well, we know that 0 doesn't equal 4, and so that's not a true statement. So if you work out the equation and this happens, we know that it's no solution. And again, we'll see some examples of that throughout the video. The third option is infinite solutions. That means every answer will work. And this happens when an equation is already equal on both sides. It doesn't matter what number we put into the equation, it's always going to be true because it's already equal. And one clue here will be that everything in the equation will cancel when you try to put it together. So you'll get 0 equals 0, or a number equals a number, any number. Or you might even cancel your what we call constants, and you might get 2x equals 2x. Well, that means that no matter what I plug in there, You know, if I put a 3 in for x, 2 times 3 will equal 2 times 3. So it will always work. And so that's when we get infinite solutions. And there's another, like 5 equals 5. Okay. So we're going to take just a minute to go through these. So you're going to have different situations. Here's some more notes that the infinite solutions are exactly the same on both sides. So just looking at two situations here, here's the examples. So you have 2x minus 6 equals 2x minus 8, and 4x minus 6 equals 4x minus 6. So you can see in the first one, it doesn't matter what I'm substituting in for x. If I take the same number and subtract 6 on one side, and the same number and subtract 8 on another side, those will never be equal. It's like starting out with $10 and take $10 each, and then taking 6 from one side and taking 8 from another. That will never be equal. So that one would be no solution. However, in the second one, it doesn't matter what number I put in there. They're already equal. It says 4x minus 6 equals 4x minus 6. So it doesn't matter what number I put in there. If we say that x is 1, that means 4 times 1 minus 6, and the other side would say 4 times 1 minus 6. It doesn't matter what number I put in there. They're already equal, so therefore infinite solutions will work. And so this is the symbol for no solution. You can write out the words no solution or put that symbol, and we just usually write infinite there for that one. All right, so we're going to take just a minute to work out some equations and look at this so that you can just have some practice problems. I'm going to try to talk as fast as I can, and you can pause this and go back through it if you need to. So here we want to think of an equation as you're trying to say 2 times something is 8. Now you may already know that. We know that 2 times 4 is 8. As these problems get more complex, it's going to be harder to think about in your head. So therefore, we want to use inverse operations and properties of equality to solve our equations. So we want to look here and see that, okay, if I don't know this, the inverse operation of what is going on here is going to undo this equation. So the other thing that we need to use is our properties of equality. So if you think about your property of equality, it says that what you do to one side, you do to the other. Now that's our little phrase, but really it says if you multiply something on one side, you have to multiply it by the same number on the other side. So here I'm going to look. Right now this is saying 2 times x, or multiplication, equals 8. So the inverse of that would be division. So I'm going to divide both sides by 2. That's our property of equality. Okay. So when I do that, the 2 divided by 2 is going to be 1x, and then 8 divided by 2 is going to be 4. So here I'm going to do the same thing over here and actually get the answer here, because we're saying negative 3 times something is 12. So that's times, so the inverse operation would be to divide, and then when I divide that, it's going to be 1x. Remember that we don't have to write the 1 in front of the x. But then 12 divided by negative 3 is negative 4. There's our sign rules again. A positive divided by a negative is a negative, so that'd be negative 4. So again, these sign rules are going to be very important, or integer rules are going to be very important as you're working through these problems. So here I'm going to take a look again at what's going on in this equation. You're actually multiplying 2 times x, and you're subtracting 5. So I'm going to think of my inverse operations. So the opposite of multiplying and subtracting is adding and dividing. So I know that those two things are going to have to take place in this equation. So I'm going to actually add 5 first. Now, there are times when you might want to divide first, and that's fine. But if I divide by 2 first here, I'm going to have to divide the 5 by 2 and the 13 by 2, which those don't result in integers. They will get fractions, which makes my problem a little more complicated. So the best first step here is actually to add 5. Now, if I add 5 to cancel the negative 5 on the side that it's on, I have to do it on the other side. That's our property of equality. So when I do that, then I get 2x equals 18, and we're back at where we were up above. This is multiplication, so then we'll need to divide by 2, And then we will get that x here, 18 divided by 2 is 9. Because there again, 2 divided by 2 is 1x. This actually says 1x equals 9. We just don't write the 1. Over here I'm doing the same thing. I want to move that negative 6 over. And negative 6 and negative 6 is negative 12. There again is our integer rules. If they're the same signs, we want to add them together. Then I'm going to divide by negative 4 on both sides. That's a property of equality again. And then, let me try to get rid of that dash there. And then I'm going to say, okay, negative 12 divided by negative 4 is a positive 3. Okay. Now remember that anytime you're working out an equation, you can actually check your solution. So by substituting it back in, just like we did earlier in the video. So if I substitute 3 back into the equation, I get this right here. Negative 4 times 3 plus 6 equals negative 6. Negative 4 times 3 is negative 12. Plus 6 is negative 6. And we can see that this is the same on both sides, so it's a true statement. So I know without a doubt that 3 is my answer. You should be able to check every equation as you work it out. Okay. I'm going to move on and go on to the next couple of questions. I do want to point out here that this equation is division. So the opposite of division would be multiplication. So here I would want to multiply both sides by 4. And so when I do that, this that would be 4 divided by 4. That's going to be 1, so 1x, and 6 times 4 is 24. So if that's division, then you want to do the opposite, which is multiplication. Okay. So here we're going to look at a little more complex problems. Here again, I'm looking to say, okay, this is division. So this is what's going on here. I'm dividing here. I'm adding here. So what are my inverse operations? And that inverse operation would be to subtract 6 on both sides. And if I do that, then I get x over 3 equals negative 3. We're right back at the equation that we had before. So then 3 minus 6 is negative 3. This is division going on here, so I want to multiply 3 on both sides. So 3 times negative 3, x is negative 9. Here's where we first see in this video the distributive property. We've done this before, but if you distribute this number, that means to multiply it by everything inside of the parentheses. Okay, so distribution is another way to say to multiply. So we're going to multiply negative 3 times 6, which is negative 18x, and negative 3 times negative 8, which is a positive 24. Notice that we're right back at the problems that we had earlier. Okay, and then, oh, give me a second. 24. Okay, there we go. So we're going to subtract 24 on both sides, and that goes away, which essentially moves that 24 to the other side and isolates our variable. So here by subtracting the 24 and negative 24 is negative 48. So you got to remember same signs to add. We're going to divide by negative 18. Now, when we divide negative 4 by negative 18, that's a positive. And this reduces the 8 over 3 because 6 goes into both of those numbers. So 48 divided by 6 is 8, and 18 divided by 6 is 3, so 8 over 3 is our answer, or 8/3. Here we're going to do the same thing. We're going to distribute. 4 times x is 4x. 4 times negative 4 is negative 16. 2 times 2 is 4x, and 2 times negative 2 is negative 4. So right here, we have a situation. Notice that your variables are the same, 4x and 4x on opposite sides of the equal sign. That means when I move one of those over, it's going to cancel and go away. This lets me know that I either have a no solution or infinite. I need to wait to see what my constants are going to do. And so the constants, when I move those over, they're not the same. They're not going to cancel. So that's going to let me know that this is going to be no solution. If you continue to work this out, I'm going to add this 16 over. And you'll notice here that with those being the same, this is what it actually looks like. So now when I move the 4x over, as we said before, it's going to go away or cancel, which is going to be 0. So this essentially says 0 equals 0 plus 12, which is really 0 equals 12. That's not true. 0 does not equal 12. And that's just another reason that this is a no solution. Okay, so there's two actual ways to tell. All right, looking up here, this is one of the ones that kind of throws people. Essentially, this is saying that something divided by negative 6 is 4. Well, if we think about that, we'll know that that's negative 24. But so in this situation, in order to figure out what that something is, I have to get rid of that negative 6. So I think about this as dividing by negative 6. So my inverse operation of dividing by negative 6 would be to multiply this by negative 6, just like you would have done if the problem was set up like this. Okay? So when I multiply everything by negative 6, I get negative 24, and then negative 6 divided by negative 6, it's 1, so we don't have to write it. So now I'm back at this type of equation. Okay, so I'm going to distribute, which is 6x minus 8 equals negative 24. And I wrote 12, sure as the world. Let me fix this. There we go. And then I'm going to add 8 to both sides. And, okay. And so then when I say negative 24 minus 8, I get negative 32, or plus 8, I'm sorry. Can't read my own handwriting here. Negative 24 plus 8, I get negative 16. And I'm going to divide both sides by negative 6. And so then I'm going to reduce this to negative 16 over 6. Sorry about that. This video is made a little bit. There we go. Let's reduce this here. All right, so negative 16 over 6. And so I'm going to divide both of those by 2 and get negative 8 over 3. Okay. All right, so last couple ones here. I know I'm getting long-winded. So negative, I'm going to distribute again and get negative 6x plus 15 equals 2x minus 15 plus 2x. So here we're going to distribute, but we have a little situation over here that we have like terms. When you have like terms on the same side of the equal sign, you have to add them together. So 2x plus 2x is 4x. Again, I'm going to move this 4x over with the 6x, and to do that I have to do the inverse operation. It's positive, so I have to make it a negative. So negative 6x minus 4x is negative 10x. Again, those sign or integer rules are important. So then I'm going to move the 15 over. It's a positive 15. I'm going to make it a negative 15. Again, those are the same signs, so we add them to make negative 30. Once again, I'm going to divide by negative 10, and then again I get x equals 3. Okay, so remember that we're combining like terms. We got to put them together the way they are. Okay, so last one here, again distribute. I've got like terms again on the same side of the equal sign here. I need to put those together, which is going to make negative 3. Negative 4 plus 1 is negative 3. Again, I'm going to make, I know that this is no solution, because I have the negative 3x that's the same, and those are different. So when I move this over, I'm going to get 0 equals negative 4, and that is not a true statement, so this is going to be no solution. So the last one, I want to talk about this one here real quick. So this is just an example of when you would get infinite solutions. So I'm going to distribute here. You can see here that when this happens, you can look at the equation. 4x minus 8 equals 4x minus 8. That's the same. I don't really need to work this out anymore because I can see that those are equal. But when I go ahead and move these around, then when I subtract the 4x, I get 0, and then I get 0 on the other side. 0 does equal 0, and so this is when I know that it's infinite. So you can just write infinite. It's a true statement, so it's infinite. Okay. All right, this is one that you're going to see on your Master Connect. This kind of goes back to 7th grade too. This is a proportion, and remember with proportions we can cross multiply. So we're going to multiply 6 by everything that's diagonal to it. That's why we say cross multiply. Proportions are the place that we cross multiply. So when we multiply that, we want to put everything in the parentheses because it's a binomial there. So we're going to say 6 times that, and then we're going to cross multiply and say, okay, 2 times x. If you'll notice here, we're right where we were before. Okay, 6x plus 3 equals 2x. Okay, we're going to move the 6 over by making it negative. Now the reason I did that is notice that there's not a constant on the right side. I have all my constants already on the left. So it's easier to move the variable over to the right. You can do it the other way. You'll just have to do multiple moves to get all your variables on one side and constants on the other. So here, because my constant's on the right with the x or the variable, I'm going to divide by -4. And then remember this is a -18 over 4. So then I'm going to reduce that to 9 over 2. So I hope this video helps. I hope it helps you with your equations, and good luck.